and today we are going to continue working in the atoms and molecules unit. So click that arrow. We are completely done with the animation, completely done with the live video. So now we're going to continue working our way through lesson 2, the make. We are going to work through step 4 and step 5 today. Step 4 is going to be a little lecture and 2 reflection questions. And then step 5 is going to be you actually building some molecules. But first, in order to do that, we need to learn how molecules are actually formed. So instead of only using this little presentation right here, I actually have my own presentation that I would like to show you. In this lecture, we're going to learn how atoms bond together to form a molecule. So we first start with a single atom with protons, neutrons in the center, and electrons on the outer shell. And then you get a group of protons and put them together, and somehow they form these amazing molecules that even with the slightest difference, they're actually end up being completely different, and they all have these fun names to them. So how does that happen? First, we're going to take a look at the different parts of an atom. You guys already are pros at this. The nucleus is the center of an atom, and it is composed of protons and neutrons. Remember, protons have a positive charge and neutrons have no charge. Next, we have the shells. The shells are where the electrons hang out. So there are different shells, and that's where the electrons stay to orbit. And electrons have a negative charge. So the positive charge from the protons and the negative charge from the electrons are what keep it together. Opposites attract, so they are holding each other together. Even though there's nothing physically tying them together, their opposite charge is enough to keep them held together. It is important to remember that each of these shells hold a different amount of energy. They represent different amounts of energy. So the first shell we already are familiar with. The first shell holds a maximum of 2 electrons. So in order for this shell to become stable, it needs to have 2 electrons. In order for the second level to be stable, the maximum number of electrons that shell can hold is 8. So if it has anything less than 8 electrons in the second shell, the atom needs to gain electrons in order to be stable. So it needs a total of 8. The next shell is very similar. So the next shell is still considered level 2 because it also has a maximum capacity of 8. So there is 1 shell with a capacity of 2, 2 shells with a capacity of 8, and the remaining shells actually continuously increase. So moving on to level 3 shells, that electron capacity actually increases to 18. So there are a couple of level 3 shells. There are actually a couple of level 4, 5, and 6 shells, all with an increasingly greater electron capacity. And those are for the really complicated atoms that are found at the very bottom of a periodic table. So that's when chemistry gets super complicated. But for us, we are going to stay in the first and second levels. We're going to stay with an electron capacity of 8. Now, whatever electrons are on the very, very last shell, those are called the valence electrons. So whatever the outermost electrons are, the electrons farthest from the nucleus, those are called the valence electrons. And those have a fancy name because those are the electrons that are going to be doing the bonding. All of these electrons on the inside, those are stable, so those are just happy and keep to themselves, while the valence electrons are the ones that are going to be reaching out and grabbing onto other electrons. Similarly, the outer shell is also labeled as the valence shell. Again, the inner shells, those are stable, those are happy, they're doing their own thing. The valence shell is the one that is holding those valence electrons, so that's where all of the bonding happens. So how does this tie into the periodic table of elements? Each one of these tiles is an element. Each one of these tiles is a very specific atom, and they are organized in a very specific way. Hydrogen has 1 proton. We move over here to helium, has 2, back down to 3, 4, 5, 6, 7, 8, 9, 10. And then we have a whole bunch of things that go on in the middle, but again, that is for when you guys are much older and take chemistry in high school and in college. It's important to know that they are organized in columns where they behave the same way. So this column over here, the very, very end, is the noble gases. They're the noble gases because they are the most stable on the entire periodic table of elements. These gases on this side have no extra room for any electrons. They are completely filled up, meaning they are completely stable. So every single one of their shells has all of the electrons they need, so they are nice, calm gases. The remaining elements, though, either need to gain some electrons or lose some electrons in order to be complete. So how do these atoms form into molecules? So first, let's start with an oxygen atom. We know that oxygen has 8 protons because on the periodic table of elements, oxygen's atomic number is 8. We also know that it has 8 electrons. It has 8 electrons because the number of protons equals the number of electrons. And those 8 electrons are organized exactly like this. 2 in the first shell and the remaining 6 in the outer shell, starting at the top and going clockwise. So top, right, bottom, left, top, right. So you go in that circular motion until you run out of electrons. So if there were 9 electrons, that 9th electron will be right here, and then the 10th electron will continue the same direction. So that means that oxygen has a total of 6 valence electrons. 2 of its electrons are in the inner shell, and the inner shell maxes out at 2, so that means that the inner shell is stable. Moving on to the next shell, the remaining electrons get distributed around the next shell until they run out. So after filling the first shell with 2, the remaining 6 got distributed in the next shell. So those 6 electrons are considered valence electrons. So because there only is 6, there is actually 2 empty spaces for 2 more electrons because the second shell maxes out at 8 electrons and there's only 6. So that leaves space for 2 more electrons to be filled in those spaces. So I'm going to slide oxygen off to the side. And now we're going to take a look at a new atom. Let's bring in our hydrogen atom. So let's take a further look at hydrogen. Hydrogen, we know, has one proton. It is the very first atom on the periodic table of elements, and it is the most abundant atom in the entire universe. So all of our air on space, as well as all of the atoms floating in outer space, majority of it is hydrogen. So hydrogen has one proton, and because it has one proton, it also has one electron. So it has one valence electron, because even though it's the inner shell, it still is the outer shell because it's the only shell. So it has one valence electron. And that inner shell, though, it doesn't max out at 1, it maxes out at 2. So there is actually one more space for one more electron. So hydrogen actually isn't stable. It has space for one more electron. So what do these atoms have to do with each other? We have our one oxygen atom, and I'm bringing in 2 hydrogen atoms. What am I doing here, you guys? Do you have any idea? Oxygen has space for 2 electrons, and hydrogen, if I'm bringing in 2, has 1 space each. So what am I doing? So what do you think I'm up to, you guys? Do you have any idea? So let me take my oxygen atom. Let's put it in the center over here. I'm going to take my hydrogen atom. I'm going to rearrange them so it's a little cleaner. Now, these 2 hydrogen atoms, all they need to do is get 1 more electron each. And this oxygen atom just so happens to need 2 more electrons. So what are we going to do? Those hydrogen atoms are going to share their electrons with oxygen. And when they share their electrons with each other, poof, a molecule forms. So now oxygen originally had 6 electrons on its outer shell, but now it has 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons for a complete shell. Now oxygen is stable. So now let's look at our hydrogen. Our hydrogen originally only had 1, but when it bonds with oxygen, it now has 1, 2. And since the inner shell only needs 2, this hydrogen becomes stable. And same thing right here. This hydrogen also becomes stable because it shares. So now it's 1, 2. So now we have a completely stable molecule. It's nice and happy. So we have 1 oxygen, 1 hydrogen. What molecule does that make? You guys have heard it a million times before. 2 hydrogens, 1 oxygen, happily bonded together, nice and stable. What does that make? Did any of you guess? H2O, water, because that's exactly what it is. H2, 2 hydrogens, 1, 2, and 1 oxygen. So 2 hydrogens and 1 oxygen bonded together forms water in any form. Water is one of those amazing molecules that it could be a solid as ice, a liquid as regular water, or as a gas as vapor. And that actually is a little bit of a glimpse of what our next unit is. Our next unit, we're going to go much deeper into solids, liquids, and gases. All right, you guys, I'm bringing you back into Mosa Mack step 4. So I'm just going to briefly go over the demonstration that they have for you there. So take a look at these two hydrogen atoms ready to bond. Each hydrogen needs one more electron to make a complete and stable energy level. So what are they going to do? They are just going to bond with each other. That is also possible. Atoms of the same kind can bond with each other to make each other both nice and stable. So now the hydrogens that were not stable individually, they bonded together, and now they formed a stable bond between each other. So they were unstable before, but now that they're bonded with each other, now they formed a stable molecule. So now it's your turn, you guys. These next two questions are some reflection questions to get you to explain a little bit about what you just learned. So now we're going to work on question 1. Describe the bonding between fluorine and hydrogen. Is the bond strong? And how do you know? So here we have fluorine, and I want you guys to count the number of electrons in the outer shell. And then we have hydrogen, and hydrogen we know only has one electron. So they bond together. Do you think this bond is complete? Would you call it a strong bond? And explain why? Now we have question 2. Describe why chlorine and hydrogen are stable, which means they have complete outer energy levels in this strong bond model. And in this picture, they're showing all of the electrons orbiting. So here we have chlorine. It has its first shell, it has its second shell. Now they're working on the third shell. So we have the third shell, and here we have hydrogen. So hydrogen is bonded to chlorine, completing its outer shell. So describe how this is a stable molecule. Once you are completely done with both questions, you may submit. And now we're going to move on to step 5. In step 5, you are going to be building your own molecules. So taking a look at their quick little explanation, there are some examples in the second slide. So here they have hydrochloric acid, which is basically just one hydrogen and one chlorine. The one hydrogen electron bonds with the chlorine to complete both outer shells. Here we just have chlorine, 2 atoms of chlorine, both needing only one electron. They bond with each other, sharing that electron with each other to form Cl2, which is just a molecule of chlorine. And here we have ammonia, 1 nitrogen atom and 3 hydrogen atoms. So the nitrogen atom needs 3 electrons. And so those hydrogen atoms fit perfectly right there to form NH3, which is ammonia, is the same ammonia that is in all of those cleaners that cleans floors and disinfects. So now it's your turn. So you're going to slide on down here, and you are going to finally put together your own molecules. So the first one is easy. All you're going to do is build a water molecule, H2O. So they give you everything already for you. They give you your 2 hydrogens that you need, and they give you your oxygen. All of the electrons are in the exact spot that you need them to be. Now all you got to do is make them complete. Where are you going to place this hydrogen in order for it to be complete? And where are you going to place this hydrogen in order for its inner shell to be complete? If you play around with it, you can't make the atoms smaller, but you can rotate them using this little square that sticks out right there. You can rotate them whatever angle you need to in order to make your atom fit. You could also rotate the main atom as well. Okay, so go ahead and make your water molecule. When you are done, make sure you hit save. Moving on to question 2, you are going to build one methane molecule. A methane molecule is CH4. C is carbon, and H, you guys already know, is hydrogen. So what are you going to do with these carbon and hydrogen molecules? Remember, your goal is to complete carbon's outer shell and to complete hydrogen's outer shell. So take a look. Carbon only has 1, 2, 3, 4 electrons in its outer shell. So it has space for 4 more. So where are you going to place your hydrogens at to make it complete? Once you're done, make sure you hit save. And now your third molecule, you're gonna make a methanol molecule, which is a type of alcohol. So you have a whole bunch of atoms to work with. A carbon, 3 hydrogens, 1 oxygen, and another hydrogen. So what are you gonna do with all of these? Make sure you're observing all of the outer shells that need electrons to be complete. Once you're done with that, make sure you hit save. Once you think you are completely correct on all 3 of your atoms, make sure you come down here and submit step 5, and you guys are done for the day. We worked on step 4 and step 5 for the day.